Okay, so last class on Wednesday, we actually started, we were talking about ellipses. And it actually started with the ellipsis centered at the origin. Well, what happens when our ellipsis is centered somewhere else than the origin? So the standard form is going to be HK. And the horizontal major axis is going to be when we have x minus h squared all over a squared plus y minus k squared all over b squared, and that's going to equal 1. And then the foci here, when this is on the horizontal axis, is going to be h plus or minus our c at k. So when we find the c, the foci, remember, is going to matter. When it's just c equals a squared minus b squared, that's when we're at the origin, and we're just going to go left or right or up or down depending on if it's which axes is our major axis. When we have it on the horizontal, we're going to have h, we're adding and subtracting the c to that, and then the k is going to be our y part of that. Now, if we have the vertical as our major axis, then this is going to be the same as x minus h squared, but instead of having a squared in the denominator, now we have b squared in the denominator, plus y minus k squared all over a squared, and all of this is going to equal 1 again. So the foci now is going to be h, and then we're going to have k is going to be plus or minus c. Can everybody see my screen? Just take yourself off mute if you can see my screen. My paper with my stuff here.
Ma'am, I actually can't see your screen.
Yeah, it's not showing anything for me.
Gotta love technology, is all I gotta say. Can y'all see it now? It may take it just a second. Hang on, it's still connecting.
I can see it now.
Okay. Thanks. So y'all didn't get any of this that you heard me talking, but you didn't get any of this earlier?
Yes, ma'am.
Okay. So I'll let you write this down. So the other Wednesday, the class, we were talking about ellipses being centered at 0, 0 at the origin. What happens when they're not centered at the origin? So now, determining which is the horizontal or vertical axis, Wednesday we discussed that A or B, depending on which one is larger, that's where the major axis is going to be. So A is greater than B is greater than, and B is greater than 0. And then to find our C, which is our foci, the formula is always going to be C squared equals A squared minus B squared. No matter where it's centered, this is always going to be our equation to find the foci. Now, when the horizontal axis is our major axis, it's going to be x minus h squared all over a squared plus y minus k squared all over b squared, and all of that's going to equal 1. Now, if you'll notice here, the foci are going to be whatever your h value is plus or minus what our c value is. And that's going to be all over k. Now, on our vertical axis, when it's the major axis, you notice that it's the same equation in the numerator, but what's happening is now the b squared is below the x minus h squared, and the a squared is below the y minus k squared. So then that means that now to find our foci, oops, sorry, I've already written it down, h, and then that's going to be our x value, and then k plus or minus c is going to be our y value. So what happens if we have this, it's x minus 2 squared all over 9 plus y plus 1 squared all over 16, and all of this equals 1. Now, if we look at this, if I take the square root of 9, that's going to be 3. And if I take the square root of 16, that's going to be 4. So remember, it's always going to be a squared and b squared in the denominator. So if I rewrite this as x minus 2 squared all over 3 squared plus y plus 1 squared all over 4 squared equals 1. Then now which one is a larger number in the denominator? The 4 is the larger number. So that lets us know that this is going to be, the major axis is going to be the vertical axis. So that means that our ellipse is going to be going like this. It's going to be going long ways this way. So if you wanted to rewrite it and put it in a different format, so the y squared, y plus 1 squared over 4 squared is in the front, then that's fine. That lets you know. If you want to keep it in the same format that it is, that's also okay. But first we need to find what our center is. We said up here that our center is always going to be HK, and our regular format is going to be X minus H, Y minus K. So what is going to be the center of this? Since it's always going to be minus H and minus K, then I know that my center is now going to be at 2, -1. So this is at the center. So 1, 2, 3, 4, 1, 2, 3, 4. So this is a -4. So if I go out to -1, there's the center of the parabola. Now, this is telling me the distance from the center. So that means I'm going out 3, 1, 2, 3 from the center here, and that's going to be an edge. 1, 2, 3. And then I'm going to go up 4. 1, 2, 3, 4. 1, 2, 3, 4. And so this is going to be my parabola like this. Whoop. Now we found the ends, we found the parabola, we found the center. One thing we have not found are the foci. So I could say that c squared is equal to a squared minus b squared. Well, we know that a is going to equal 4, b is going to equal 3. So we have c squared equals 16 minus 9. 16 minus 9, I'm figuring that to be 7, equals c squared. So c is going to equal the square root of 7 and the negative square root of 7. Oh, can't see my work, sorry. Now remember, if you put this in your calculator, you have to solve for y, and in doing so, you've got to make sure that you're you multiply by the 16 over. Then you would subtract this, and you need to take the square root. So there's a lot involved when you're putting it into the calculator, but you can do it. Just make sure you're putting it into the correct place. So any questions about this before I move over? So as long as you remember the horizontal major axis, the a squared is under the x squared, the b squared is under the y squared. It always tells you the major axis is going to satisfy a is always going to be larger than b, and b is always larger than 0. So when we found this and we're given this, we knew the square root of 9 was going to be 3, and the square root of 16 is going to be 4, then this has to be our a because it's larger. The a is always going to be larger than the b. So then we satisfied the vertical axis here as our major axis. Sorry, guys. Hello? Hello? Uh-huh. Thank you. We don't have an alarm system for the house, but we have one for our chicken houses, so. Okay. So what happens when we're given an equation of 4x squared minus 16x plus 9y squared plus 59y plus 61 equals 0? So if you don't remember, this is going to be a completing the square deal. So we have to move over anything that doesn't have a variable with it. So we've got 4x squared minus 16x, and I'm going to leave a little space for my completing the square here, plus 9y squared plus 59y equals, sorry, this is a 54. I don't know why I said 9. Just make that 9 look like a 4. There you go. Negative 61. Now complete the square here. So to complete the square, we take half of our x term here, and then we square it. So half of this is 8, and then I'm sorry, this is half of this is 8. That's not going to work out right. Did I write it down wrong again? Oh, we can factor out this 4 here. I'm sorry. And this will make it a lot easier. So half of 4 is 2. 2 squared is 4. So plus 4. And then if we factor out a 9 here, then we've got y squared plus, and then this is going to be 6y. And then half of 6 squared is going to be 9. And that's going to equal a negative 61. And then we're adding back this 4 times this 4, which is going to be 16. And the 9 times the 9, which is going to be 81. So instead of having these big numbers to deal with, we're actually taking them out first. So now we're going to say 4, this is x minus 2 squared plus 9 times y, and this is a perfect square, but it's going to be 3 squared, because 3 plus 3 gives me 6. And this is equaling up to negative 61 plus 16 plus 81. So negative 61, hang on. And you should get a 36. Now, those who were not here the other day, you have to have, our equation always says we're going to equal to 1. And so that's how we end up getting our denominators over here. So if I divide everything by 36, then 4 is going to go into 36 9 times, 9 goes into 36 4 times, and 36 goes into 36 1 time. So now I have x minus 2 in parentheses squared all over 9 plus y plus 3 squared all over 4, and that equals 1. So to find this, we're going to say that our center, and our equation is always negative, so this is going to be 2, negative 3. And if we look at this, then I'm going to say this is, I'm just going to mark this out and call this 3 squared and call this 2 squared. So the 3 is larger. So this is actually going to be on the horizontal. So I'm at 2, negative 3 here is my center. On my x-axis, I'm going out 3, so I'm at 1, 2, 3 is an edge. 1, 1, 2, 3 is my other edge. I'm going up 2, 1, 2, down 2, 1, 2. And so you can see that this ellipse now is going this direction. So it looks like it's kind of laying down. So once you graph these, I am actually just going to, instead of me drawing everything out, pull up the PowerPoint slides. So this is the last thing we're going to be covering this semester is hyperbola. And the hyperbola are set just like, kind of like the parabolas, where we had a parabola, if we didn't look at this part, and this was our parabola, the focus is always going to be where it's curving toward the curve. So in the hyperbola, that's going to be the same thing, except for you're going to have two of them because you've got two different ways of looking at the hyperbola. Now, when we're looking at this, the standard equations for a hyperbola are x squared over a squared minus y squared over b squared equals 1. And this is a hyperbola where the center is at the origin. And the vertices are at positive and negative a 0, and then your asymptotes are going to equal y equals b over a, and that's also going to be a positive b over a and negative b over a. Now on this one, the foci are still going to be at plus or minus c0, but now our formula is c squared equals a squared plus b squared. Because if we look here, we actually have, when we draw this out and we can sketch this, if we have this diagonal and this diagonal, we see that these are the two diagonals in which these are staying. If my vertices are at A and B, and I can draw a thing through here, then we can see that from point to point to point here on your foci, then we have a 90-degree angle because we've got our transverse diagonals through here. We're forming a 90-degree angle here with our two foci and a point on the hyperbola. So that's where we get now our c squared equals a squared plus b squared. So this is going to show us if the hyperbola, here's our foci, the center is at the origin, but because the center is at the origin doesn't mean the vertex are going to be at the origin. We're going to have this. Where this distance here is our B, the distance between these, and then this distance here is going to be the A. So when we're looking at our other way of drawing a hyperbola, foci, the vertices, so we're going to be doing this form, and you can tell then our formula is going to be y squared over a squared minus x squared over b squared, and that's all equal to 1. The vertices are going to be located at 0 plus or minus a, and then the asymptotes are going to be at x y equals plus or minus a over b times x here. And then y is going to equal plus or minus a over b times x here. So when we're on the, our foci are on the horizontal, then to find the asymptotes, you're doing y equals a plus or minus b over a times x. When it's on the vertical, you're doing y equals plus or minus a over b times x. And then our foci now are located at 0 plus or minus c, where c is c squared equals a squared plus b squared still. So any questions? Any questions from the peanut gallery? Of 6 people, 5 people?
No.
Your test will be posted today, and I did get clarification today. Maddie, if you want to put this in, so all the math instructors should have gotten this, that our exams are going to be online. We were told to give y'all 4 to 5 days, which I usually give you about a week anyway, to do the exams, and they will be timed, just so you're not going to have time to look up everything, but you will have plenty of time to do it. So make sure that you've got your formula sheet there that you printed off from your Blackboard. You can use that for your final exam. You can use your calculator for your final exam. And I would go through and just write notes about stuff, and the more you write, of course, the better it's going to be. So if you can go through and write notes and then go in and adapt those, that'll be fine. But they will be timed, and you will have to get it done. So your Unit 4 test will go online today. Your final exam will probably go online next Tuesday or Wednesday. So we do supposedly have class on Monday. That'll be more of a review than anything. So if you have questions, I'll be here and available. I mean, I will be on a Skype, so we can do the same thing. But just let me know, and if you have any questions between now and then, you can text me or email me. I'm trying to stay up to date, but if any of you are trying to register for summer classes, it's been a nightmare. So just hang with it and try your best. Is there any questions? Any questions about the projects? Okay, if you can still hear me, then unmute, please. I know a lot of you got a lot going on in the houses, and so you got probably speakers and stuff on. So, but if you have any questions at all, let me know. Have a wonderful weekend. Enjoy your test later today, and I'll see you Monday. If you Skype in on Monday or talk to you Monday. So, Matt, if you want to stay online, then we can have our weekly meeting. If anybody else has got a question, speak now and we can answer it.
No, ma'am. Thank you.
No, ma'am.
So, Matt, are you still there? Okay, I got your message. So the test is going to be just through hyperbolas. I think the thing said that we were supposed to go back and let me see. Do parametric equations, but I'm not going to worry about that. They can pick that up in Math 140 or whenever they go to Clemson in their 1080 class. But if you have any questions, just let me know. You can text me and we can just do our meeting over text if you want to do that, or email me. But I can send you would you like for me to send you the email that I got from the math department, just putting down about the exams and stuff? Okay, I will do that. Have a good weekend. Stay safe. There's supposed to be another storm coming through from what I hear. I'm afraid to look at the weather these days, but stay safe. And I will talk to you later.